Today we're going to create this neat little game where if you enter a seed and click play game, you can collect some blocks, and if you collect enough blocks, you end up winning the game. So here you can see I can jump around, I can click to mine, I can mine my way down, and if I mine enough iron, I think the amount is set to like 15, it will then allow me to win the game. But if I keep mining, it then says, hey, you won, you want to play again? If I click cancel, it'll just let me keep playing in like sandbox mode. If I click OK, it takes me back to the home page. If I click play game again, I can mine some grass. And then if I right click, I can place the grass. If I come down here and I mine some dirt, and I come down here and I mine some stone, I can change this to place the stone or the dirt if I'd like. Or maybe I have like stone selected and I want to place dirt. If I left click or middle click the dirt, I can then place it with the left click. So we have all of the basic functionality that a game like Minecraft will have here. We just have the graphics of a potato. So to do all of this, and again, this is running off of a GitHub Pages page, so this is all going to be hosted. You won't have to pay for any of it, don't worry. To do all of this, what we're going to do is we're going to use P5.js. If I come over here and I search for editor.p5js.org, it will give me a P5.js website. If I come in here and I say, all right, I'm logged in, if I hit Control S, it'll save the sketch. I can now come over to File and click Download. Once I download it, I can download it as a zip. I'm going to name this to something like, I don't know, video sketch, and then I'm going to save it. I'm going to come down here, click show in folder, right click this and click extract all, hit enter without reading because reading is hard. Once that's done, we then have a folder. We're now going to type PowerShell.exe in this little bar right here, which will allow us to open PowerShell in this directory. I can now type code dot to open this up in a VS Code instance. Now that that's done, I'm going to go ahead and move the VS Code over to the left. I'm going to move this window over to the right, and I'm going to resize things a bit so that we can still see, but we can't see a lot. Now I'm going to come over in VS Code to extensions, and I'm going to search for live server. Live server is an extension that we're going to use to create a basic little server that we can host HTML out of. Once we have that, we can right click on index, open with the live server, and it'll open this up. It's telling me I'm already using port 5500 for the demo that I showed you because I'm running it on local as well. I'm going to grab the 5501 port then. You can use 550, it doesn't matter. And I'm going to paste this into Brave, and it'll open up the window in Brave. Once that's done, we can go ahead and get started. Now let me make sure that my audio is recording because I've managed to mess this up a couple times today. All right, looks good. Let me open up my notes because there's a lot of them. And then let's go ahead and get started because I really don't have a lot of time today. A lot of stuff to do. So what we're going to do is we're going to open up the index.html page. Inside of the index.html page, we want to set some stuff because we need a home page. We're going to start by giving ourselves a title. Title is just the name of the window up here in our tab. I'm setting it to block miner. We're then going to create a couple of divs. We're going to create a H1 here that says, do you want to play a game? P if you win, or you win if you manage to mine any of the following. We then create a UL, which we can just type UL for and hit tab if you're into that. And then we can do a LI, which is going to be LI times 5. And you'll see right here, Emmet abbreviation. We can hit tab and that opens up the LI. If you don't have Emmet enabled, you can go into File, Preferences, Settings, search for EMMET, tab, and then trigger expansion on tab, set that to have a checkbox, and then you're good to go. Once you have that done, you can go ahead and copy some of these values in. This is just the number of blocks you need to mine to win the game. You win if you mine 128 grass, 64 dirt, or 32 stone, or 16 iron, or 8 diamonds. Once that's done, we then give them a little good luck tag right here. We get rid of this script tag right here because we're not going to use that. But we need to add in a form for redirecting to the play page. So we're going to do a form with a method of get, and then we're going to do a number input. So it's going to be an input of type number with a name of seed and a placeholder that says enter a seed without a value because we don't have a value yet. We're then going to do a input for the submit. So it'll be input type submit, value of play game, and then on click. Now this on click is going to be interesting. Essentially what we need to do, I'm going to paste it in, our on click here, and I hit F11 to full screen, is going to be this .form.action, which is setting where this form will go. We're setting the location of that to be the location.pathname, which is going to be our URLs, whatever comes after this. So like slash, I don't know, if you have like slash blog slash 5, you're going to grab this slash blog slash 5. And then we're going to say plus the playgame.html. And the reason why we're doing this is because if I come over to Chrome and I come back over to the page that's hosted on GitHub Pages, it's not hosting this on deanout.github.io/playgame. It's hosting this on /block-minor-demo, which is the name of the repository. So we need to keep the repository name whenever we do a link here. It's kind of a pain, but that's why we're doing this weird form action location path name thing. But okay, once that's done, we can go ahead and save this. And we now have a home page here. We can enter a seed 1337 and click play game, and it takes us to a page that doesn't exist yet. So let's make it exist. We have that power. We're going to right click and say playgame.html and save that. I'm then going to type shift and 1 for an exclamation, hit tab to open up a basic HTML doc, and hit Control S. We can come over here, hit Control R to refresh the page, and now we're good to go. We're going to replace this document here with our block miner. We then need to include our style sheet and our P5JS nonsense. So up here in the head, we're going to put this right here. We'll save all that, refresh the page, nothing will happen. We can get rid of this meta stuff right here and our viewport, don't need that. So what we need to do now at the bottom here in our body, we're just going to throw in our sketch.js, which will once again give us that weird, ugly gray blob. We're then going to create a div for the top bar, and then we'll go ahead and close this div. This top bar is just our little toolbar that has all of our block stuff in it so that we can select it and see how many we have. We then create a bunch of divs in here. Each one has an ID equal to whatever that block is plus restart. It has a block type for the class, and then it has a value of 0 inside of it. Unless it's the reset button, then it says go home. Once we have all of that, we now need to style this. And styling is usually kind of boring, so we're going to breeze through that too. So it comes with some default styling. We're going to leave that because it just gets rid of some of the padding the browsers provide. We create a top bar that has a vertical height of 10, so that's just 10% of the screen. And then we give it a background color of an ugly gray with a display of flex and a flex direction, and then we tell it to align the items in the center. But of course, the items listen about as well as I do, so we then need to grab each of these. So we can do that by styling the block type because each of them is a block type, as you can see here. And then we give each of these a display of flex, a flex direction of row, and a justify and align, which puts them in the middle. We then give them a width and a height of 100%, so they take up the entirety of their little block that we've given them. We give them a color of FFF, which is just white for the text. We give it a text shadow, which just gives it that little bit of a drop shadow. And then we set the cursor to a pointer so it looks like you can interact with these, but you can't. We then come in here and we say, hey, if you have a block type, you want to have a hover, and then you're just going to have a weird gray color if you hover on it. That gives us the ability to hover on all of these. And you can even say something like exclamation mark important if you want to, and you'll see why in a second. We're now going to give each of these a color. We'll give this one a grass color. And if we don't have this important here, and then we refresh, it doesn't do our on hover, which is kind of weird. If you want to do an on hover for each of these, you can just do grass colon hover, and then set your on hover to be a different shade of green. In my case, I'm taking the lazy way out and just making it so that if I hover on it, it changes the color. Now we have a couple other blocks here, including our restart button. These are all just going to be different colors. So grass is this green, dirt is this weird grayish green, stone is this other gray, iron is this other gray, diamond I tried to steal from Minecraft, but it didn't go well, and restart is just a black button. If we hit Control S, you can see all of these different buttons appear here. They don't look great, but it's, you know, a basic skeleton that we can work with. The last thing we have is the ability to set an active one of these. So if I save this and come over to Chrome, you can see whichever one of these I click on is set to active, which gives it that orange outline. So that's all this little active thing is doing there. It's just giving us orange bars around it. Once that's done, we're then good to open up Sketch and spend the rest of our foreseeable future in here, because this is going to be a long one. So what we want to do is we want to set the width of the container to be equal to the window width. We then want to set the height of the container not to be the container height or the window height. We actually want it to be 90% of the window height, because the bar up here is taking up 10%. We then grab the width, paste it in here, and the height, paste it in here, hit Control S, everything is now gray. Not to be confused with great, although things are going pretty great right now. We want to create a block size. We're going to set the block size to 25 because we're creating neat little blocks on the screen. And then we're going to come down to our setup, and we're going to set the frame rate. Frame rate's going to be 15 because we're using some movement logic. And then we're going to set a seed. Now the seed that we're setting isn't going to make a lot of sense right now. If you aren't familiar with procedural terrain, I created a video last week about doing procedural terrains. I'll have a link to it in the video description. And if you go watch that, a lot of the procedural stuff will make a lot more sense. But basically, whenever you have a procedural terrain, you can set a seed, just like in Minecraft. And if you put in the same number, you'll get the same terrain each time. Now, in the case of this application, we set the home page. Whenever we set the seed, it passes it in as a URL parameter up here. That's why it says $seed equals whatever. We can grab that in vanilla JavaScript. We just say set the query string equal to the window.location.search. We grab the URL parameters from that query string, and then we can check if we have a seed in our URL parameters. If the URL params has a seed, we set the seed to be equal to those URL parameters. We can then set the noise seed for P5.js, which uses Perlin noise by default, to have that seed. And we can even set our random number generator to have the same seed every time, so that when we place OR, they're always in the same place. If you don't want ORs to be in the same place every time, don't include this random seed line. If you don't want the terrain to be the same or even settable, then don't include the noise stuff right here for the terrain. But okay, we have this. Let's now create a generate terrain function in our setup. And then let's come down here and do a function to generate the terrain. This is going to be a pretty straightforward one. If you watched the video from the other day, essentially all we're doing is we're going to say let x equal 0, x is less than width, x plus equals the block size, because we're iterating in terms of 25 because each block is 25 wide and 25 tall. We don't need this stuff right here. Don't know what that's about. But what we want to do instead is we want to say, let's do let rand value equal random, and we can do a random between like 0 and 10. We then say if the rand value is less than 5, we want to set the fill color for this, else we want to set it to be white. So we'll set the fill color here to be a fill of 255, or no, a fill of 0. And then if it's greater than 5, we'll set the fill to be white. This is just going to very quickly disappear because in our draw function, we have a background set to 220. That's going to keep drawing over this every frame. Instead, we're going to hit Control S after we get rid of it. And now you can see this weird crossword looking background that we have here. So this is great, but it is random. Random's kind of boring, kind of cringe. So instead, what I'd like to do is generate some noisy terrain. To do this, we're going to need to create a couple variables up here, which again, watch the video from the other day that's linked in the video description. But essentially, we're going to create a frequency. Frequency is going to be equal to 0.02. We're going to create an amplitude. The amplitude is going to be set to 1 for right now. And we still need to create our seed. So we're just going to set the seed equal to 0 for now. We'll hit Control S and nothing will change. So once that's done, what we can do is we can say, all right, we have a seed, we have a frequency, we have an amplitude. I know this one. I'm going to comment out all of this stuff. And actually, before I comment it out, I'll just show you a neat little trick. What you can actually do is you can take the rand value. So in this case, we have a random value between 0 and 10. What you can do is you can say rand value divided by 10 times 255. And this will give you this neat little gradient effect that just colors it based on how high the number is. The higher the number is, the darker the color. So that's one thing you can do. And we're now going to apply that same sort of concept here to our procedural terrain. So we need to start with a noise value, and this noise value is going to be equal to noise, and you can see here x times frequency, y times frequency, but then at the end here we need to do both of those times the amplitude in case we change the amplitude. Once we have that, we can then go ahead and plot this if we'd like to. What we can do is we can say, I don't know, let's say the fill color is going to be, fill is going to be noise value times 255, and we'll create a rect with that noise value. And you can see here we get this neat little gradient effect. If we change the frequency, let's say we decrease it, everything looks much more zoomed in. If we increase it, you get a bunch of random noise that no one knows what it's doing. I'm going to move it down to 0.02 because it's a nice medium for right now. I'm going to get rid of this random stuff because the noise is just objectively cooler. And then I'm going to get rid of this fill stuff because we don't need that. And instead what I'm going to do is I'm going to create a node because we're going to be using nodes for this. Each of the nodes is going to have an X. There's a random bug on me. It's going to have a Y. It's going to have a density, which is just going to be the height. I just like to think of it in terms of density instead. And it's going to have a block type, which is going to be set to terrain by default, except I don't like that. So let's just set it to a variable called sky. And then let's come up to the top and let's say let sky equal quote sky. And what we need to do here is we basically need to create all of our block types. So we have grass, dirt, stone, iron, diamond. We're going to say this one right here is going to be grass. This one's going to be dirt. This one's going to be stone. This one's going to be iron. And this one's going to be diamond. So we grab the grass, paste it in, grab the dirt, paste it in, grab the stone, paste it in, the iron, paste it in, and the diamond, paste it in. So the reason why we're doing this is because we're going to need these strings all over the place, and we're not in TypeScript, so we can't create an enum. So we're just using this sort of hacked together solution. And once that's done, we actually need to come up here one more time and say let grid equal a empty array. We can then push this grid item or push this node into the grid. We can grab an index of this node in the grid by calling grid.indexOfNode, and then we can paint the terrain tiles. So that's going to be a function called paint terrain tiles, takes in a node, takes in an index. So we can come down here, we'll say function paint terrain tiles. The first thing we want to do is destruct this a little bit. We're going to grab the X, the Y, and the density from the node. We're then going to do a noise amount. Now the noise amount is going to be the density times Y. So the same thing we were doing up above where we took the value times 255, except here we're taking the value times Y. So if the density is 0.25, 0.25 times Y will be somewhere around here. It's less likely to be up here. Now this is the opposite of what we want because we want the terrain to be down here and less likely up here. So what we do is we just invert this by calling or setting a Y level equal to height minus Y, which means our 25% is now from here down basically. We now say, all right, we got all that. We want to set a noise amount. If the noise amount is less than the Y level, we need to do some stuff. What we're going to do is we're going to set the block type equal to sky, which of course we have our variables, so we'll just use our variables. And then we need to set a fill color, and we need to create a rect. Now we don't have this fill color yet, so we got to come up to the top and create this fill color. Now all of these fill colors are similar to the ones we used in the CSS earlier, so you can copy those, but we also have a player color, which is just set to a hard red. I'm going to move up the iron so it's a bit more organized. I'll move sky up to the beginning. So there are all your colors. Feel free to pause it and take a look at those. I'm going to Control S, and now you can see that our sky is filling up wherever the sky is, and we have this negative space where the terrain needs to be. So to get the actual terrain to paint itself, we basically need to do a couple more checks. We have our one check for the sky, which is if it's below the Y level. What we can do now is check if it's above the Y level times 0.6, and if it is, we set it to be equal to grass, which gives us this neat little grass effect. We, of course, need to get rid of this and change it to be the actual grass variable. We can then set all of the dirt using a similar method. So we set the noise amount if it's greater than the Y level times 0.8. So that's all the dirt. And then we have the stone. And then we have the stone, which we can paste in here. Let's get rid of these, change them to variables, save all that, and that gives us all of our stuff. Now this looks pretty ugly, and the reason why is our frequency is still too high. So let's add a 0 here, hit Control S, and now we have the smooth looking terrain, but it's boring because there's no ores yet. So let's go ahead and let's paint some ores. To paint the ores, we're going to need a paint ores function after we paint the terrain tiles. So we'll say paint ores, which takes in a node and the index. Then we can come down here and we can create this function. The paint ores function just paints the diamonds, then it paints the iron. So we need to create a paint diamonds function. Now this is going to look very similar to our terrain generation because the first thing we do is we destruct the node by grabbing the X, the Y, and the density. We then create a noise amount and get the Y level. The next thing we do is we say, all right, is the noise amount of the Y level greater than Y, or is the noise amount greater than the Y level times 2? Because as we do this, times 2, as we do this, the more we multiply the Y level, the lower down it goes. So this is going to be pretty far down, which is why it's already suggesting that we use the diamond block type here. So this is everything way down here. If I take this and I multiply it by 5, it goes super far down. We're going to do times 2, which gives us this, but we don't want all of this to be diamonds. So what we can do is we can say, and is the diamond chance greater than a random number between 0 and 100? Now, of course, we need to set the diamond chance. So we need to come up to the top here and set what this variable is. So below the grid, we're just going to add 2 different variables, one for the diamond chance, which is going to be 5%, and one for the iron chance, which is going to be 8%. Now you can see we get like a couple different diamond ores down there. And that's pretty much all we have to do to spawn the diamonds. So now let's go ahead and let's paint the iron. I'm going to uncomment the iron, come below the diamonds, and we're just going to paint the iron. It's going to be the exact same function right here. The only thing we change is the level that it spawns at. So iron can spawn a little bit higher, and we set the iron chance to be out of 100. And we set the block type here to be iron. We can then save this, and now you see we get a little bit of iron here, but it's all spawning in the same place because we set those seeds earlier to have the same random location. If you wanted to change that, you just comment this out, save it, and now you get a different iron and diamond ore location every single time. If you comment out the noise seed, you get a different terrain every time. Now, of course, because of how this is set up, we can also get a different terrain by just changing the parameters up here from 1337 to 1338. Gives us a completely different one. But we're going to stick on 1337 so you can get the exact same results that I have. So now we're painting the terrain. Let's go ahead and let's add in the player controller. So let's come up to the top, and the first thing we need to do is add in a jump height. So we have our jump height. We also need to add in a is falling Boolean to the player, and we need to sort of create a player because we don't have one right now. So what we're going to do is we're going to say let the player have a X and a Y. We'll close this. The player then needs to have that is falling. And we're going to give the player an inventory while we're here. So the player is going to have an inventory object with grass, dirt, stone, iron, diamond. And these are just going to be the values up here once we set those. We also need to set a selected block type. This is going to be which one of these we've clicked on. Which we'll set up later. But for now, we'll just set it to be the grass block type. That's just the string for grass is all we're doing there. We have the, we need to do our setup. In our setup, we need to do some event listeners. So we'll do those real quick. We'll add in the event listeners after we generate the terrain. And then we need to set the active container, which we'll do right now as well. So what the containers are these things up here. And to set the active container, we first need to get all of the containers, which we gave them the IDs earlier in the HTML file right here, the grass, dirt, stone, iron, diamond. So we need to get all of those, which we'll do right here by calling let grass container equal document.get element by ID grass, dirt, stone, diamond, iron, and then restart for the last one. So that gives us all of those. We then need to set or create the active container, which we set to grass by default. Okay, so that gives us all of those things, none of which we're setting right now. So let's come down to our event listeners, which we'll do, I guess, below the draw function. What we'll do is we'll call a function, or we'll create a function called do event listeners. And the first thing we want to do is if we click the restart button, so restart button.add event listeners on click, we want to call a restart function. Now the restart function is pretty simple. We'll do it right here. Restart is just going to grab the URL. It's going to say the window location href. It then grabs everything except for the last page that you're on, and it takes you there. And the reason why we don't just go to like redirect to / is because in the GitHub page, it's going to be the GitHub repository. So if we come over here, it's deanout.github.io/blockminerdemo/playgame. And I want to go from /playgame to blockminerdemo when I click on this button. So we have to make sure we keep this part of the URL right here, which is why we're making this super generic. It is kind of a bit of a pain to play with that way, but if we save this and we click go home, it now takes us home. So that does do something for us. Now, in the event listeners, we do have a bunch of other stuff we need to add, though. Namely, we need to add we need to stop the right click when we right click opening this context menu, because we can place blocks with right click. To do that, we can add an event listener for the context menu and set it to prevent default. If we save this, come over here and right click, we can't do it anymore. The next thing we need to do is for each of the containers, we need to set the selected block type for the player. So we're going to come in here. We're going to say, all right, grass container, add event listener on click, player.selected block type, which we set earlier, is going to be of type grass. The reason we do this is essentially when we go to right click, place a block, we grab the player selected block type, which we initialize to grass, but here we need to set it to whichever one we're clicking on, which of course means we need to do this a bunch more times. So we're going to come in here and we're going to say for the, for the dirt, for the stone, for the diamond, and for the iron, do the exact same thing. We just need to change all of these to not be strings, because that is very spaghetti codey, and it's from my demo, so that's why it's spaghetti code. But that gives us all of those event listeners there. The next thing we want to do, because we added in all of the event listeners and this set active container, is we need to actually create this set active container function. So we're going to do this by coming down here. We can do it right below the event listeners. We set the active container to be the to remove the active class list if it has it. We then set the container.classListAdd to be active. So because of how we're calling this, we have an active container, which we've previously set to whatever we clicked on. We get rid of the active class there, so it's no longer highlighted or whatever. We then add the active class to whatever container we're setting here. So here we're passing in iron, so it'll set it for iron. And then we set the active container to be equal to container. And now if we click on these, you can see it toggles between all of them. So we can now tell which one's active. Now we can't actually use it yet because we aren't using these blocks, but this will allow us to use it when we need to. Now, in terms of using it when we need to, we probably want to be able to place blocks, and we probably want to be able to break blocks, but we also need to have a player to do all of that. So to add the ability to do those things, we need to come up and in the, in the draw function, which we're going to grab and we're going to move up here right below setup, just so things are a bit more organized. In the draw function, we need to do a player movement. So we're going to say do player movement. And then we need to create this function. This is going to happen at the bottom because there's a lot of logic that goes into this. So we're going to say function do player movement. Now for the do player movement, we need to start by drawing the player. So to draw the player, it's just a quick function that does a fill for the player color. It takes the player.x and the player.y and sets the block size for that. That gives us this red little box up here. Now that's great, but now we want to be able to move. So let's say we want to move left. Now we start on the left. So we should also do the ability to move right. We'll just do both at the same time. So we'll create two different functions. Now for the player to be able to move right, we need to do a couple things. The first thing we need to do is we need to make sure that we're not moving to the right if we're already at the edge of the screen. So what we're going to do is we're going to say if the player.x plus the block size is greater than the entire width of the screen, then we've gone too far. We need to go back. So we're going to return. Then we can do a check to see, all right, if the right arrow key is down, and if you don't want to use the right arrow key and instead you want to use like WASDA, you can do single quotes and the letter D, I think, to check if you're moving right. In my case, I'm going to leave it as the right arrow because it's what I have working right now. We then need to check if the right arrow key is down and if the block we're trying to move to is a sky block. So if the right arrow key is down and the block we're trying to move to is a sky block, then we can do stuff. Now, the important bit here is we don't have this function yet. So we need to create the find node function. So we're going to create a function, call it find node. And this is going to take in quite a few things, but I need to first find the function in my notes. It's going to take in a X and a Y. It's then going to calculate the node X and the node Y. And it does this by saying, what's the X? The X might be 503. We take 503 minus the remainder of X divided by the block size. So in this case, it's 25. So we take 503 minus 503 divided by 25 with a remainder of 3. So 503 minus 3 gives us 500. We do the same thing for Y. We can then loop through our grid to try and find this node. So if all of these bugs would stop landing on me, that'd be fantastic. But what we do is we grab this node. If this grid's node.x and .y are equal to the one we're trying to click on here, we then have found our node. And if we found our node, we just need to return this grid element. So basically, we're just checking to see if the values we have match up with a node in our grid. If they match up with a node in our grid, we are then good to continue with the moving right. So we're going to go ahead and we're going to say, all right, we need to move right. So we'll just update the player position. Now to update the player position, we grab the player.x and we add the block size because we're moving right. We do need to create the player move position or player update position function though. So to do that, we need to pass in a new X position and a new Y position, which will then cause us to set the previous player position, set all of the players X and Ys, and set the new player position. Now, the reason why we do a previous and a next, if I save this, is because when we start falling, we need to update where we've fallen from. So let's go ahead and let's add in player gravity before we do this. That way you can see what I mean, because that might make it a bit easier. So if we come up here, after we do move left and move right, I'm going to comment these out real quick. We then have do player fall. And what we do with the do player fall is, if I just grab this function real quick, for the do player fall, we check if we are above the bottom of the map. That way we don't keep falling if we're at the bottom. And we set player.isFalling equal to false. So if we're already at the bottom, we're not falling anymore, which means we're good to keep moving and we're good to try jumping off the bottom of the world. We then need to find the node that we are trying to fall to. So we do the fall, or we do the find, and we grab the player.y plus 25, which is the block below the player. If the block below the player is equal to a sky block, then that means it's not a solid block, so we need to fall to it. So we set player is falling equal to true. We then need to update the player position with the player.y plus block size. And then the last thing we need to do is if we're not actually above a sky block, we need to set player is falling to false. If we press play now, you'll see that we fall, but we have this weird looking trail. How do we get rid of this trail? Well, like I said earlier, we need to come down to the player update position, and we need to get rid of the previous player position. If we hit save now, we start here, we fall, nothing updates. And the reason why nothing updates is because we need to set the new player position as well. So we set the new player position. Well, actually nothing's updating because we don't have this function yet. I'm dumb. Let me get rid of that again. We need to set the previous player position, which is just a function that sets the fill to be the sky color. Set Control S, and now nothing happens, and then we appear at the bottom. So to get it to update our position each time, we also need to set the new player position, which I'll put down here. And now you should see, if I actually call this function up here, that the player position gets updated in real time as we're falling. So there is your falling now, and if I try to move right or left, nothing will happen. The reason why nothing happens if we try to move right or left, if we come up to the player move right, is because we actually have player move right commented out. So let me uncomment it, and now I can move right. I can't move left yet because we haven't implemented that feature yet. So what we'll do is we'll uncomment the player move left. We'll grab the player move right from right here, paste it below. We change this plus to a minus. We also rename this to be left, and we add in the E. We then check and change this to either A or the left arrow. We change this to a minus, and we change this to a minus. We hit Control S, and now we can move left and right. We can't jump though. So how do we do jumping? Well, we come up to the player movement, and when we do the player movement, after we finish with the falling, we then need to do a check to see if the player is not falling, and if they're not falling, we can then do a player jump. You can also return just in case you have more logic down here. It's not necessary though, because it will just implicitly finish running the function. So what we need to do is say function do player jump. And to do the player jump, we do a little bit of magic because we need to do some checks to make sure that the block above us is good to go. So we have our jump height of 3. Essentially what we do is we just check if the up arrow is held, or you could change it to the space key. And if the up arrow is held, we then check the block above the player by subtracting the block size, and we update the player position to be that. Now the issue with this is we're only jumping 1. So what you could do is you could check and multiply this by the jump height. The problem with multiplying it by the jump height is if you have a block 2 blocks above you, it'll check the 1 block above you, but it won't check the block 2 blocks above you. So to get around this, rather than doing a check each time, because we might change how much we're jumping, we just add all of this into a for loop, and for each of the iterations of the for loop, we just check the block, and we check if we're holding. So now we can jump up 3 blocks. So okay, we can now jump, we can move left, we can move right, we can't, but if we go to the edge of the screen, we crash. So to change or to fix that, we need to add in some logic to all of these. So for our player fall, we're already checking that we're above the map. For our move right, we're checking if we are at the edge here. For our move left, we actually need to not check if we're greater than the width. We actually need to make sure that we are not going less than 0. If we do that, we can now try to go to the edge of the map and we don't crash. Let me just go check the right side real quick to do a sanity check. It looks like it works, so we're good to go. Okay, so now that we have all of that, we now have the jumping stuff figured out. We should probably handle the clicking to mine blocks and all of that. So to do that, we have a function in P5.js. It is called the mouse pressed function. We'll put it at the bottom. So we have a mouse pressed function. First thing we do is we check what the node that we clicked on is. We then check if the player can interact with this node. If the player can interact with this node, we then do a interact with node function call. So what's this interact with node look like? Basically, we create a function that takes in a node. It checks what the distance to that node is by calling the P5.js distance function, which takes in an x and a y for the first object and x and a y for the second object. We then check if the distance is less than or equal to the block size. Let's say you want to be able to click 5 blocks away. The way you do that is you take this block size times 5. It's really that simple. So once we implement the mining, we'll come back and we'll take a look at what the interaction looks like. But we need to create this interact with block function. To do this, all we do is we say, is the left mouse button held? And is the block that we're trying to interact with not equal to the sky type? because we don't want to be able to mine sky blocks. That's kind of weird. If it's not a sky block and we're holding the left mouse button, we then want to mine the block, and then we want to return. So we need to implement a mine block function. Now this sounds scary. It really does, but it's actually pretty simple. We create a function, call it mine block, pass in a block type for the, or we get the block type from the node. We then add the block to our inventory, which we need to do still. And then we call a draw function. We also need to not pass in the sky block, but instead pass in just the word sky. So let's start by adding the block to our inventory. And this is where GitHub Copilot's really going to shine and hopefully save my butt. We're going to call this add to inventory. And then once we're in here, we're going to do a switch on the block type. And then for each of these, we're going to do a case for the grass, like it's suggesting. If it is of type grass, we add it to the player's inventory grass object or integer, whatever we set it to. We then check if it's dirt. If it's dirt, we add it to the player's dirt. If it's stone, we add it to the player stone. If it's diamond, we add it to the player diamond. And if it's iron, we add it to the player iron. If it's a default type, we just do a break, just like that. And now we have the ability to mine blocks, but nothing else is happening. The reason why is we need to create this set and draw node type function. So we'll say function, set and draw node type, takes in a node, takes in a block type, and then it just has a fill color set to the block type's color. That's not right. We need to actually get the color. GitHub Copilot thinks that I'm smarter than I am. So instead, we're going to create a function that gets the block type's color. So to do this, we're going to create another switch statement that GitHub Copilot's going to magically create for us. So we just create a function with a switch. And then in here, we check if the case is of type sky, then return the sky color. If the case is of type grass, return the grass color. If the case is of type dirt, return the dirt color, et cetera, et cetera, et cetera. And we just go through for all of our different block types. And then we have a default, which just returns the sky color. We now need to create all of those colors. Oh no, we actually have all those colors. I'm losing myself. So now that we have that, let's try to break the block below us, and we can dig below us. We can't dig more than one block away though. So to change that, essentially what we need to do is in our interact with block, in our player can interact with block, we just multiply this by whatever we want. If I set this to 5, I can then mine 5 blocks away. If I set this to, I don't know, 1.5, you can then see that I can mine, if I come over here, I can mine not 1 block away, but I can mine diagonally. So maybe that's something a bit more like what you're looking for, but that allows us to do our mining. So we have our interact with block. It now allows us to mine. What we should do next is check if we can place a block. So to do that, all we do is we come below the mouse button left. We set a mouse button right. We check if the block we're trying to place a block on is sky. If it is, then we call a place block function. Place block is another one of those that seems kind of heavy and hard to implement, but if we come down here, we can just paste the whole thing in. Basically, we take in a node, we set the block type to be the player's selected block type, which we set up earlier. That's what we can click on. We then check if the player has enough resources, which is a function we need to create, which takes in a block type. And all it does is, in this case, it's just checking to make sure that the player.inventory block type is greater than 0. I don't think that'll work. So instead what we'll do is we'll do a switch for the block type. And what we'll do is we'll check if the case is grass. If it's grass, we check the player's grass inventory. If it's dirt, check the dirt. If it's stone, check the stone. If it's diamond, check the diamond. If it's iron, check the iron. If it's default, I don't know, go cry. And then once that's done, we can then check all of those. So I'm going to break some grass, I guess, and then try to place some grass and see if we can place more. Looks like we can't place any more, so we've used up all of our grass. That's pretty cool. What I'm noticing though is that we're not setting whatever block we're trying to set here. So it's working now, but with the grass, we weren't updating the counter. So what we need to do is we don't just need to check the current inventory, we also need to set it. And we can do that in the draw function. If I search for it. In the draw function, after we do the player movement, we want to update the player inventory. This is going to be a function that just does a whole bunch of ugly HTML stuff. So we already have all of these elements up here. What we want to do is create this function real quick. Just say function, update player inventory. And in here, all we want to do is grab all of our inner HTMLs from our containers and set it equal to the player's inventory value. If I Control S on this, nothing will change here yet, but if I start mining, you'll see that my grass counter up here is now up to 5, which means I can place 1, 2, 3, 4, 5 grass blocks, and then no more. So that's just going to do all of our updating for us. Now, another thing we can do in the interact with block is, if I search for this function actually, in the interact with block, after we check for left and right, we can also check for a center mouse button press. So mouse button equals center and the node type does not equal sky. Then we can set the container to be get block type by container, set the active container, which we're already doing. And then we can set the player selected block type to be that block type. Now I do need to implement this, I think. So let's go ahead and let's scroll down to the bottom and let's get the container by block type. So we'll just do that real quick. So we implement this. If we now hit Control S and let's actually change all of these to use variables. Basically, we just grab the block type and then we grab the container based on the block name. It's not the cleanest implementation, but it works. And what we can do now, if I click on diamonds, which I don't have any of, and then I left or middle mouse click on grass, it changes to grass, and then I can, of course, place it. So that allows us to do our middle mouse button functionality. The last thing that we really want to do here is we want to add the win conditions. So if we scroll up to the top, right below all of these diamonds and stuff, maybe below this, we can set a amount to collect. So our grass, dirt, stone, iron, diamond, I just set it to powers of 2. And then if we come into the draw function, we just want to check if the player has won, which means we need to implement that function. So let's come right below the draw function and implement it. What we're going to do is we're going to say if the player, check if the player has won, and we're going to wrap all of this in a continue playing loop, which means we're going to need a Boolean up here that just says let continue playing equal false, I guess. And then we just do a check initially, and if we have it set to true, then just return. And this is what's going to allow us to check if the player doesn't want to go home, they just want to keep building or something. So if we aren't continue playing, then we want to check if we've won, in which case we need to do player.inventory.diamond is greater than or equal to the diamond to collect. If it is, first thing we do is we set continue playing to true, and then we say if window.confirm you won, play again, question mark. If the player clicks confirm on play again, we then call the restart function. So same thing as going home. And that's pretty much it. The only difference is we don't want it to just be for the diamonds. So what we can do is we can say or player.inventory.iron or stone or dirt or grass. And the reason why we check it in this order is because it's easier to get 8 diamonds than 128 grass. So you're more likely to hit this, so you're checking less conditions, I guess. I don't know. It's also just the order that GitHub Copilot generated it in. So now that that's done, we have the continue playing. We can hit Control-Shift-I to see what it's unhappy about. Oh, we need to do one more brace here. We have all these nested loops. It's kind of ugly. There we go. The formatting was a bit off. So now if we collect blocks, we can click on them to place them, etc. We can jump, we can move, we can mine. The only thing we need to do is check if we can win. And to do this, we're going to cheat. I'm going to set the grass to collect to be 5. So we'll just watch the grass counter right here. 1, 2, 3, 4, and then 5. Play again. I'll hit cancel, and now it'll let me do stuff, and nothing will happen anymore. But if I refresh and I collect 5 grass, 3, 4, 5, and I click OK, takes us to the home page. Okay, that's great. Now let's take this and put it on GitHub. So to do this, we're going to come over to a PowerShell window, I guess. So we have this PowerShell. I think this is the directory we're in. Let me just check. Video sketch. Yep. I'm going to type, I'm going to hit Control plus a bunch of times. I'm going to hit F11. We're going to type git init to initialize git repository, git add dot to add all of our files, git commit -m init commit to commit our files, and then we can do a git push, but first we need to create the repository. So we're going to come over here, go to github.com/whatever your name is, and then you're going to expand this a bit. I'm actually going to full screen it. Top right, click plus new repository. We'll call this block breaker. We can then add a description, the official repository for the block breaker game. We'll click create repository. We won't select anything else. And then we can check SSH. In my case, you can also use HTTPS if you want to log in with your username and password. I'm going to use SSH though, because I have the key set up. We'll click on the copy button right here, come over to our console, right click. It'll ask us if we want to paste. We'll hit yes. We'll hit enter. It's going to tell me I can't access this because I actually need to open this directory in a Ubuntu instance. So I'm going to come over here and I'm going to CD out of my blank sketch and CD into the video sketch. I'm then going to do the same thing. I'm going to say paste all of this, push. It'll push up my code. That'll go up to GitHub, which now has all of the code. We're then going to come over to settings. We're going to come down to the pages button. We're going to click on this, select the main branch, click save, and it'll now tell us that it's pushing our site up. If we come back to the top level of the repository and we come over to actions, I think it'll tell us that we're running this build. If we click on the build, we can see where we're at in the deployment process. So right now it's just queued. What we can do while that's building, maybe you come over to settings and you want to do a social preview. You can click edit and upload an image. So what we'll do is we'll come over to our block breaker. We'll say 1337 is our seed. And we'll refresh the page. And now maybe you want to put your player in the middle, and maybe we'll dig a little bit of a hole just so that you can see that you can mine. I don't know, something like that. I'll hit cancel. And then we'll just put our player right here. And then we'll grab a screenshot. I'll hit Windows, Shift, and S to do that. And then I'll just highlight some of the playable space. Maybe I'll just highlight this. And then we can open up Paint. We can move this over. I'll hit Control S to save this or to paste this. Hit save as PNG. I'll save this in my downloads folder. I'll save this as my thumbnail. Minimize this, come over to GitHub, upload an image, and we'll go to downloads, upload that image, and that'll give you a nice little preview that you can see on your repository. You can also check your sponsors if you want people to be able to sponsor you when they see this repo with your super high quality code. So now that that's done, we have our GitHub pages right here. It says it's active. We're going to right click this, open a new tab, and it's going to say view deployment. We click on view deployment and we have our website right here. I'm going to say 1337 is our seed, play the game. Mine 1, 2, 3, 4, 5 blocks, and now we're good to go. You can of course change the number of blocks you need to mine back up to 128 if you want to. If you do that, let's say 128, hit Control S, come back over to your Git stuff, do a Git status. You'll see that that file changed. Git add dot, git commit -m, update win conditions. And then do a git push. That'll push it up. If you come over to your actions now, you'll see that the page is already being automatically recreated. So that handles all of your rebuilding. And that is how you create an entire game in about an hour. I know we went pretty fast, but I thought, you know, it'd be cool to see just what we could get done in an hour. And I think we actually came in just under an hour. So that's going to do it for me. Hopefully this video was helpful. Hopefully this is an interesting portfolio project for you. And if it is, consider subscribing, and I will see you in the next video. Thank you for watching.